Hello, my name is Colter Koch Harbison. This is my presentation for ME 575, Materials for Additive Manufacturing. The research paper that I was assigned was sensors. As you can see in the left picture, this is a setup of the test done within the research project. I will later go into the different components and actually how this testing works. The title of my research paper that I was assigned is Demonstration of a Polymer-Based Single-Step Waveguide by 3D Printing Digital Light Processing Technology for Isopropyl Alcohol Concentrational Sensor. Below the title is the list of the three authors, and below that is the journal name, Photonic Sensors. It is volume 12. It was done in 2022 and is 13 pages. The specific scope of study for this project was application of polymer materials for optical waveguide sensors and detection of alcohol solutions. And the main objective or question addressed was how can this be done faster with a higher sensitivity? So the actual product that was made in this can be seen in the leftmost image. It almost resembles an upside down T that is extruded. Within that leg of a T, there is a cutout. This cutout is known as the waveguide gap. The distance or thickness of this gap is one of the variables that I will be talking about later when regarding the testing that was conducted. In the middle image, this is actually the sensor chamber. Within the sensor chamber, you have the actual waveguide that sits in it. The sensor chamber has two holes. The first hole allows for light input. Within this test, there is an LED source connected by a fiber optic patch cable that brings light to this light input. The gap of the waveguide aligns with these two holes, so that light after its input travels through the gap and then goes to the output hole of the sensor chamber. So the output hole is also connected to a fiber optic patch cable that is then connected to a power meter. The results that are given to this power meter are given to a computer that actually presents the data. Within this sensor chamber, there is an alcohol container. Within this alcohol container, obviously alcohol is put in, and the toxicity of the alcohol goes in the air, and that's what's actually being tested. The amount of alcohol that goes into this container is the second variable that I will be talking about later that is changed and tested upon. So the waveguide is a single-step alcohol sensor. It is made using the material Monocure Rapid 3D Clear photopolymer resin, and this resin has a refractive index of N equals 1.5. You can see a picture of this resin to the right. The process of which the researchers actually made this product began in Autodesk, a CAD platform. So they constructed it within that CAD form, downloaded it, and converted it to a file that would be compatible with a 3D printer. As pictured to the right as well, the 3D printer that this was done using is a Wanhao Duplicator D7 box DLP. So like I was talking about earlier, the first variable that was tested upon is the difference in the transmit optical power dependent on the different waveguide gaps. So if we first want to go over and look at the leftmost diagram, you have two different situations. Situation A is a leaky type structure, which means that there is not an alcohol presence within that substance being tested. And the second section, or the second diagram, is B. It's a guided type structure, which means it does have an alcohol concentration. If you want to look at the gap now, so the diagram that does not have an alcohol concentration, you can see that the light reflecting light is very sporadic. The light is going at angles, whereas the guided type or the second diagram, the lines going through the gap representing the light are very parallel. So the graph to the right shows 5 different tested gap uh, gap dimensions. As you can see, the highest gap occurs at 300 UM, or the highest power occurs with a gap at 300 UM. So the researchers then decided that this was the um, optimal gap size for that power increase that they were looking for. The second study is the second one that I had mentioned previously. It is regarding the difference in optimal transmitted power, as well as humidity and temperature based on different amounts of that isopropyl alcohol amount. Um, so the left graph shows that the power within these 3 tests, there are 3 different liquid amounts used. Within all 3, there is the biggest numbers presented within the 10 UL tested amount, has the highest power, has the highest percentage of humidity, as well as the highest temperature. So the relationship can be made that increase in the amount of isopropyl alcohol also increases these 3 different components. So in summary, the researchers were successful in figuring out a solution to detect the alcohol within the air. Um, like I've said, they used a polymer-based horizontal, just single-step waveguide, and they were successful in this. So the study was conducted on a variation of products. They did 5 different products with different waveguide gaps, and then tested that on 3 different liquid amounts. And the results of these studies were shown within graphs, as well as calculations and other components within the research paper. Overall, the report was very clear and concise. The data and results were displayed effectively, and it was clear to the reader as to what the objective was, what the process was, and ultimately what the end result was. Thank you for listening to my presentation, and I hope that you learned a little bit more about sensors.